Alright, so this is the review for test 3 that we're going to be doing tomorrow in class. Review for test 3, and test 3 is covering domain and range and continuous and discrete functions. Alright, so number 1 says the price P in dollars for apples depends on the weight W in pounds of apples. This situation is represented by the function rule P equals 199W. So what does that function rule mean? What's 199W mean? The cost is $1.99 per pound, right? All right, so first we're going to make a table for this situation. So I gave you the W values we're going to use. So let's plug in our P values. So P equals 199 times 1. So what's 1 times $1.99? $1.99. 199. So P equals 199 times 2. 3 what? 3.98. And P equals 199 times 3. 5.97. P equals 199 times 4. 7.96. And then 5 times 199? 9.94? 5, sorry. Alright, so to create a mapping for this relationship, I'm going to create a mapping from this table. So my domain values are 1, 2, 3, 4, and 5. My range values, in order from smallest to largest, are 199, 398, 597, 796, and 995. So in this case, 1 goes to 199, 2 goes into 398. So in this case, all my domain and range values are in order. So my arrows all go straight across, right? Are there any questions so far on the table or the mapping? We're okay with those so far? Alright, C and D I think were the trickier parts of this problem. So before we do C, I want to do D. So is this a continuous or a discrete function? Why continuous? You're exactly right. Why? Why is it continuous rather than discrete? Yes, well, a discrete function can keep going also, right? But here in my table, I listed only whole numbers. Do I need only whole numbers to find the price of fruit? Can I buy half a pound of bananas? No?
Oh, yes, you can.
Yes. So, is the weight of the bananas only on whole numbers? No. So this is going to be a continuous function because the weight can be fractions of a pound. Continuous because the weight of the bananas can be fractions. All right, and I think this is where the domain and range is going to be a little tricky. So remember we said if it's a continuous function, then our domain and range are going to be inequalities, right? If it's a discrete function, our domain and range are going to be a list of points that agree with that function, right? So here if I have a continuous function, am I going to list the points from my table, Or do we need to write an inequality? An inequality, right? So here, my domain are my x values, but what do I call the x values for this situation? W's, right? So I'm going to say W, so my weights are greater than what? 0, right? Because I could buy a fourth of a pound of bananas, right? Alright, so if my weight is greater than 0, then what do I know about the price? It's greater than 0 also. Perfect. So my price is greater than 0. All right, are there any questions on number 1? No? All right, think it over. If you have questions, let me know at the end. I can come back to it, okay? Number 2. Number 2, again, we're finding function values. If I give you a domain value, can we find the range value and vice versa, right? So the first thing I'm going to do is I'm going to fill in my table here. I want my table to be filled in. So I've got x. I've got my function, x minus 5 will give me my output, y. So I've got a process column here. So what we're going to do is we're going to fill in that process column. So I've got x is negative 2, so I'm going to say negative 2 minus 5, negative 1 minus 5, 0 minus 5, 1 minus 5, 2 minus 5. So then I'm going to find my function values for each of these given domain values. So negative 2 minus 5 is negative 7, beautiful. Negative 1 minus 5, perfect. 0 minus 5, 1 minus 5, beautiful. And 2 minus 5 is negative 3. So all of my y values are just increasing by 1, right? Very good. So now let's use this table to find the function values. So when x equals 1, so when x is 1, the value of y is negative 4. Right. When y is negative 2, I'm going to go to y. Oh, wait, is negative 2 on my y, one of my y values? No, but it's really close, right? So if I just increased one more to have negative 2 here, so what should that x value be? 3. Perfect. And finally, when x is negative 1, what is y? Negative 6. All right. Are there any questions on finding function values from a table? You feel pretty comfortable with that? All right. Number 3. Number 3. Thank you, sir. Number 3 says, use the table below. Is the relationship a linear function, and how do you know? So we're going to, this is kind of what we were talking about yesterday. I put together what we did yesterday and what we were doing last week. So here I've got a table. First of all, is this a function? Yes, why? The x's don't repeat. So I can say a function because the x's don't repeat. Perfect. All right, now I want to know, is it a linear function? So, yes, because my x values, all of my x values increase by 1, increase by 1, increase by 1. What about my y values? From 8 to 1, that's a decrease by how much? 7. From 1 to negative 6, that's a decrease by 7. And negative 6 to negative 13, that's a decrease by by 7. So here, do I have a constant rate of change in my x and y values? Yes, so I'm going to say a linear function because, oh, I forgot an E. Sorry. There is a constant rate of change. Please turn your music off, Ellen. I can hear it all the way over here. Yeah, I can hear it. All right, number 4 says find the domain values of the function f of x is equal to negative 2x plus 5 when the range is 19, 7, negative 11, negative 15, and negative 31. All right. So I have the function f of x is equal to negative 2x plus 5. I want the domain. I want the domain when the range is given. So which is given, the f of x or the x? The f of x. So what we have to do is we have to plug in each of these values for f of x and solve for x. Is there a faster way to do this? Yeah? You think so? How would I do it? No? All right, well, let's plug them in and see.
Well, I think there is, but I'm just not completely.
Well, how could I use the calculator?
Like specifically this calculator?
Sure. How could I? We could graph it, and then what? So we're going to plug the graph in. So let's do that. So hold on, I'm going to project a calculator. No? Why is it anyone's fault? Let's see. There we go. Oh. All right, I made someone my presenter. So I want everyone to practice this. This is how we're going to do it. So I want everyone to go home. I want everyone to go home. Oh, wrong screen, sorry. There we go. I want you to add a new document. Home on your calculator home. I want you to add a new document. We're going to add a graphs page. So new document number 1, add a graphs page.
Wait,
Yes.
Oh no, I was looking for the graph, but I found it.
You found it?
I'm not the presenter.
I think you're presenter, sir.
Oh wow.
So add a graphs page. So no, don't save if it asks you if you want to save. All right, so we're going to add a graphs page. So press menu, hon. Menu's on the right side. There you go. Add a graphs page. So we're going to graph that function negative 2x plus 5. Is that what it says? Yes, negative 2x plus 5. And graph it. All right, so we've got our domain and our range, but I gave you a specific set of range values, right? Which were, what were they? 19, 7, negative 11, negative 15, negative 31. What can I do to find, well, when y is 19, what is x? What could I look at? We could look at the y-axis, right? So we could actually plot a point on here and then scroll up to that 19, right? What else? What about the table? You want to look at the table? All right, so how do I get to the table from here? What about Control T? T for table. Control T. Hey, look at that. So what I'm going to do is on the y's, so that f1 of x, we need to look for 19. So if we go down, that gets negative, right? We want positive 19, right? So go up and see if we can find positive 19. Up, 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 up. Hey, so negative 7 is the x value for positive 19. So that's going to be my first domain value, negative 7. All right. Sure. So then we're going to find 7. They're already there, right? So positive 7, what's my y value? Sorry, what's my x value? Negative 1. All right. Negative 11, we've got positive 8. Negative 15 is 10. Ooh, negative 31. Hey, that wasn't too far down there. 18. Thank you. Let's give our presenter a round of applause. Thank you, sir. Oh, where did I put my remote? All right, so I filled in, as we were finding these, for my domain, negative 7, negative 1, 8, 10, 18. Is that the only way to find those domain values? That was pretty quick, though, right? So the other way would be we could plug in, so I'm going to do just one. We could plug in 19 is equal to negative 2x plus 5, and then solve for x, right? So that's another way to do it. All right, are there any questions on finding domain values given range values, or finding range values given domain values? There's a lot of value there, right? So are there any questions about number 4 right now? No? Okay. Let's take a look at number 5. Number 5 says, determine whether each of the following relationships, there we go, sorry, is continuous or discrete, and I want you to justify your answer. I need to change colors here. So A says, Kenny buys mixed nuts at a corner market for $4.50 per pound. The cost is a function of the number of pounds bought. So is that discrete or is that continuous? Why continuous? Because he can buy fractions of a pound. Perfect. Because he can buy fractions of a pound. Beautiful. B. Perfect. So, about renting a hotel. A hotel charges $90 a night per room, and they charge an additional $8 for each person. And we can only have up to 5 people. So this one's going to be discrete because, say it one more time for me, Ty. You can't have half a person, and can you have half a night? No, they're going to charge you for an entire day, right? So this one's going to be discrete for 2 reasons. Beautiful. Discrete because people and nights are counted as whole numbers. All right. Number 6, we had a problem just like number 6 for our warm-up today. So I'm going to read it because there is a typo that I want you to fix. I want to give you an opportunity to write the equation for this problem, and then we're going to check it together. So 6 says airline passengers pay $275 to fly to Florida. For this price, customers may check 3 pieces of luggage. There is a fee of $30 for each additional piece of luggage a passenger wants to check. Write a function used to find the amount in dollars a passenger has to pay to fly with P pieces of luggage, where P is greater than or equal to 3. I wrote 2. See, I wrote 2. That should be P is greater than or equal to 3. Because they can check 3 pieces of luggage for free. So I'm going to give you guys a moment to write this equation. This is just, bless you. This is just like our warm-up. Finished it? Okay. You might want to check your work, just in case.
So 3 are free, but for any additional,
So 3 are free, but every additional one is going to cost $30. And that's expensive. Surely 3 would be plenty, though. I guess it depends on where you're going and how long you're staying, huh? All right, so what should my equation look like? Oh, is P equal? P is our pieces, right? So did I give us our total? A variable for our total? Well, that's for the ticket, right? But for the cost, remember in the warm-up I said C is cost? Did I give us so we could do C. Do I have to do C this time, though? No. But C looks pretty good. C for cost. So C is equal to, how much did our ticket cost? $275. And then the cost for our luggage. So plus 30. So is it 30 for every piece of luggage? Every piece of luggage after how many? 3. So I'm going to say 30 times P minus 3. Right? Because after 3, it's going to cost us. And that's where P is greater than 3. So if P is less than 3, we wouldn't use this equation. We would use a different equation. Okay? And that equation would be just the 275. Because it's free up until then, right? Number 7. Number 7 says one type of redwood tree has an average height of 65 feet when it is 20 years old. If the tree is more than 20 years old, the average height h can be modeled by the function, and then I left off the function by accident because I copied this over from another document and left my equation behind. So the function is h equals 1.95 times a minus 20 plus 65, where a is the age of the tree in years. So which statement about this situation is true? I'm going to pause for a moment because I see lots of people writing. All right. A says every additional 1.95 feet of length over 20 feet adds 45 years of age to this type of redwood tree. Okay. B says for this type of redwood tree, the average height increases by 1.95 feet per year throughout its lifetime. C says each additional year of age over 20 years adds 1.95 feet to the average height of this type of redwood tree. Or D, for this type of redwood tree, the average height increases 65 feet for every 20 years of growth. So, here my equation says, well, at 20 years we have 65 feet, right? So, and then this a minus 20. So we're going to say every year after 20, right? We're going to add how much? An average of 1.95 feet to it, right? Which answer choice does that match? I think it matches C. C says each additional year of age over 20 years adds 1.95. So that's after 20 years, because that 65 feet goes with the 20 years. Adds 1.95 feet to the height of the tree. Number 8. 8 says, which of the following graphs does not represent y as a function of x? So, if we're looking for a function, and I'm given a graph, what kind of test am I going to use? The vertical line test, right? So here on A, does A pass that vertical line test? Yes, it passes. What about B? B passes, right? What about C? C passes. What about D?
Epic fail.
It is, because it's a vertical line, right? It is a vertical line, so it can't pass the vertical line test. Perfect. So I'm going to make myself a note here. It must pass the vertical line test. Perfect. Number 9. Number 9 says, what are at least 2 ways to determine if a relationship is a function? The vertical line test, we just talked about one of them, right? The vertical line test. What's the other one? None of the x values repeat. Perfect. You've got this, Ted. The x values cannot repeat. All right, number 10 says write a story for each of the graphs. Tomorrow I'm going to have 3 stories, and I'm going to ask you to match them to 3 different graphs, or not these exact graphs, to 3 different graphs. But today I asked you to write 3 stories for me. So what I want you to do is write me 3 stories, and then we're going to talk about them, and I'm going to write down one story for each one. You're welcome to work with your group to compare answers if you need to.
You don't understand? We have to open our mouths.
Did you write me a story? Write me a story for all 3. Okay. All right, let's take a look at these 3, you guys. So for A, can I get a volunteer for A to share their story? Yes, Ted. Ooh, so a plane flies, so this would be the distance, right?
I got one.
So like the vertical distance, right? The distance above the ground. So A, I'm going to say a plane flies at a constant height then you said rapidly descends.
I thought it was red.
Well, let's do B.
Yeah.
So, because I'm only going to write one for each one. All right. And then this was time, right? So for B, what was the scenario someone had for B?
I was falling.
So you were falling,
Then I caught myself.
then you caught yourself.
Then I started stumbling.
Oh, if you go up, are you going to
You
stumble?
can't stumble up. That's
You're going to increase in height, right?
Are y'all not seeing this?
Just imagine like.
So this one,
Drops,
so you fall down a hill,
then he runs.
and then, let's say, what would happen if it were constant straight across? Are you falling anymore?
You can't stumble upwards.
So you stopped falling, right?
Fell.
Okay, you fell.
And then if he,
Now it's a straight line.
Okay.
and then it goes up, so then what happens to go up? So he climbed the hill slowly, right?
Trying to kill
I
himself.
saw one.
Then he started running again, like Naruto.
All right, hold on. We're gonna write down B. What? I need just one scenario. So can we all have different scenarios that work though? Yes.
Yes.
So
No.
I'm gonna say I fell down a hill and rested at the bottom for a while, right? Perfect. At the bottom for a while. Then I got up
Is it because it's so?
and started to slowly climb the hill.
No, I said I would climb to eagle and jump down to
All right. What do we got, sir? What do you got for C?
A man climbed up a hill and jumped off. Then an eagle came and took him up to the
Okay. So if you start at the bottom, you climbed a hill.
No. Son Goku flies in the air, punches his enemy, falls down.
Would it go straight up? Well, whoa. Time out. Would it go straight up?
Time out.
It'd be more curvy, you think? Because of the weight? Okay. So, let's start with the, you climbed a hill and then, well, if we're going, this is pretty quickly, right? So I could say I ran up a hill, ran down the other side, right? And then, I'm trying to think of something that runs and flies. So I like the idea of flying. What kind of bird runs? So a bird runs up a hill, and then down the other side, and before he reaches the bottom, he takes flight and flies away. I like it. So a bird. No. We're not gonna go. It's not dove season yet. We're not shooting down any birds. So a bird runs up a hill, gentlemen.
What, mine? Because it sounds cool? No.
Then down part way, right? Then down most of the other side.
Can you like just leap instead of fly? Like just leap.
You can change this to leap if you want. Then the bird takes flight.
Oh my God, that's an epic one.
Be sure to write down any epic ones you think of.
It would be like duck hunt.
Then takes flight. Alright, you guys. I want you to hang on to this review for you to study. Be sure you bring it to class with you tomorrow. This will be due before our exam.